Hello everyone, welcome back to Believers IAS Academy Bengaluru. This is topic of the day. Today we'll discuss about recent cloud seeding initiatives in Delhi. So recently what they did was they started doing artificial cloud seeding and artificial rainfall in Delhi to control pollution. So today we'll discuss what is this artificial rainfall and how is it helpful in controlling the pollution. So the topic name is, has cloud seeding been effective? Examining India's first cloud seeding trials in nearly 50 years and what they reveal about artificial rainfall technology. First, Delhi's historic cloud seeding. This particular experiment is the first time in nearly 50 years that Delhi conducted cloud seeding trials in collaboration with IIT Kanpur in October 2025. Aim was to induce artificial rainfall. So the major goal was to settle the smog and particulate matter during the severe air pollution episodes. So normally why we do cloud seeding and the artificial intelligence is, sorry, not artificial intelligence but artificial rainfall. Artificial rainfall normally is done in the dry arid regions. Okay, normally it is done in the dry arid regions because of the lack of rainfall, because of the lack of waterfall. But in Delhi's case it is not because of the lack of rainfall, but it is to reduce or control the pollution. Okay, next, however, both the trials failed to produce measurable rain, raising critical questions about the effectiveness of cloud seeding, especially in the post monsoon atmospheric conditions where Delhi's air quality reaches hazardous levels. Post monsoon, because of various reasons, Delhi's air pollution reaches to almost 500 plus levels in air quality index. Why? There are many reasons. First is obviously the cold region and the geography of Delhi. Geography of Delhi is it lies in center low lying area. Wait a minute. Okay. If we take this the geography of Delhi, okay, Delhi lies in the cold low lying region in the surrounding areas. So what happens here is the air subsides here. Air subsides here. As a result, anything that is being pollution or anything that is being created in Delhi stays in Delhi only, which reduces the or reduces the visibility and increases air pollution and reduces air quality index. Add to that the stubble burning issues in neighboring states such as Haryana and Punjab. They also bring together the pollutant, smog, fog, everything to Delhi and subside there only. Because of the western disturbances, the air coming from this particular region, it brings along the pollutants to Delhi and subsides there. And also, again, like whether you agree or not, Deepavali or Diwali also has impact on the Delhi's air pollution levels. Okay, because of this, during the colder dry winter regions, so winter periods, Delhi experiences high level of pollution. Okay, but the key challenge is post monsoon clouds in Delhi lack sufficient moisture for effective seeding. What is there in the post monsoon clouds in Delhi? It is completely filled with pollutants rather than the moisture. What you need for rainfall? You need moisture, some sort of moisture. So that is the reason why the trials that have been done till now in Delhi have been unsuccessful. Okay, so first we'll discuss the static part. What is cloud seeding? So cloud seeding is a weather modification technique designed to artificially induce rain by spraying salt mixtures into clouds using aircraft or rocket. Okay, so obviously it is copying the natural phenomenon of rainfall by artificial way. Okay, where rain will condense in the clouds and then there is Bergeron cycle, there is hygroscopic nuclei, where as a result the rainfall happens. So we copy the particular method. So we induce hygroscopic nuclei, and around the hygroscopic nuclei moisture condenses. Once the moisture condenses, it will go through Bergeron cycle. Bergeron cycle is condensation, convergence and collisions. All this happens and results in droplet formation. When the droplet increases and when it reaches the dew point, it will bring rainfall. So that is copying the rainfall. Next, partial injection. The first step is salt mixtures such as sodium chloride, calcium chloride or silver iodide are sprayed into the clouds using aircrafts or rockets. These salt mixtures act as hygroscopic nuclei. Hygroscopic nuclei. What is hygroscopic? Those are in love with moisture, in love with water, meaning hydrophobic is repel the water molecules, but hydroscopic is they attract the water molecules. That is what the hydroscopic nuclei, around which, if this is the nuclei, around which all the water molecules start condensing. Next step is condensation nuclei. That is, the particles act as the hygroscopic or condensation nuclei around which water vapor or ice crystallizes crystals coalesce. Okay, coalesce. So this is part of the Bergeron cycle. Bergeron cycle. What happens in Bergeron cycle? First is they start colliding the water molecules, then they condense, and then they coalesce. Coalescence. So together they are called as Bergeron cycle. Next is droplet formation. After the Bergeron cycles, water molecules gather around the particles which form droplets. From the droplets, it will convert into drops. And finally, rainfall. When enough droplets combine and become heavy enough, they fall as the rain. So normally, if this is the cloud, it has to reach the carrying capacity. So when the cloud reaches its carrying capacity, it will result in rainfall. This particular point at which the cloud reaches the carrying capacity is called as dew point. It is called as dew point. When the cloud reaches the dew point, it will result in rainfall. Next, goal in Delhi is to use this light rainfall that can help suspend the particles, suspended particles like particulate matter PM 2.5, PM 10, and clear the smoke from the atmosphere. That is the major aim, not to bring rainfall or anything, to reduce the this particulate matter. Next, historical background about this artificial rainfall. In the 1940s, it was discovered in USA. William Schaefer and Bernard Wannert at General Electric discovered cloud seeding using the dry ice. They were successful in snow induction over the Massachusetts, led to Project Cirrus. Project Cirrus in 1947, in an early government program to control weather and hurricanes that ultimately proved unsuccessful. Even then, it was unsuccessful, but the discovery was done in US only. 1950s and 60s, it started going to rest of the world. The global adoption. The technique gained worldwide popularity. Soviet Union used it to clear the skies over Leningrad, and China deployed it before the 2008 Beijing Olympics, and the US ran project Skywater using silver iodide over the Rockies. So aim is to bring rainfall or clear the skies. So for various reasons, many countries started adopting it. Okay, next, India's journey in cloud seeding. So this was the first time India used in Delhi. Okay, doesn't mean that India has not done any cloud seeding trials before. India has done it in many areas. Even in Karnataka also we have done cloud seeding. First, in 1952, first trials, S.K. Banerjee, Director General of IMD, conducted India's first cloud seeding experiment in Kolkata using silver iodide and common salt released via hydrogen balloons. So this was the first attempt. And in 1962, Delhi attempt. Cloud seeding was attempted in Delhi but failed to produce any results. Next, in 1970s onwards, aircraft era. Aircraft-based spraying began with multiple state-level drought mitigation projects. Drought mitigation projects, especially in the dry arid regions of Maharashtra, Karnataka, and Tamil Nadu. Okay, result was there was mixed outcomes. Uncertain rainfall contribution, high operational cost, and lack of verifiable data plagued early efforts. Okay, so whatever the impact was there, it was successful in some areas but unsuccessful in most of the areas. Next, CAPEX, CAIPEEX, India's scientific breakthrough. What is this? Cloud aerosol interaction and precipitation enhancement experiment. That is CAPEX. Okay, it was initiated in 2009 by Indian Institute of Tropical Meteorology, which is present in Pune. CAPEX aimed to scientifically assess whether cloud seeding enhances the rainfall in Solapur, Maharashtra, which is a drought-prone region. So method was researchers used a radar and aircraft to identify seedable clouds over the seedable clouds which has at least some sort of moisture level content. Fired calcium chloride flares into the clouds and kept others unseeded for comparison. So when they compared this, they were able to identify how this particular experiment was able to successfully seed the clouds. Next, Delhi's 2025 trials. What went wrong in Delhi's trials? In October 28, 2025, IIT Kanpur first conducted the trials using its own aircraft to induce light rain and reduce particulate matter. It resulted in minimal results because there was no significant rainfall recorded. Only few minor results in few areas with marginal air quality improvement. So it was partially successful or mildly successful, but it was not to the extent that it was expected. Okay, root cause lack of suitable moisture bearing clouds in the post monsoon season. So CAPEX had shown that only monsoon clouds with adequate humidity are seedable, which is a condition absent in post monsoon atmosphere. As I told you, because it is a winter season and because already the rainfall has passed through Delhi, the clouds are unseedable, meaning clouds have lesser moisture. Next, challenges and limitations in this particular case. Cloud quality. That is, it works only with the clouds having sufficient moisture for vertical growth. Post monsoon and the winter clouds in Delhi are too dry for effective seeding. They are very dry for effective seeding. Then, verification difficulty. That is, hard to prove if the rain occurred because of seeding or because of natural process, making scientific validation very challenging. Then, high cost aircraft, salt chemicals, hygroscopic nuclei, and trained personnel make cloud seeding an expensive intervention because aircraft is not a easy task. You have to like spend lots of money for this aircraft, and also chemicals are also not very cheap. They are also very costly. And again, you want to have only trained professionals. That is also very costly. Next, temporary impact. Even successful rain has only short-term impact or short-term effect on the air quality, requiring repeated operations. Okay, so you are going to bring the cloud seeding. The suspended matter is the particulate matter is going to suspend to the ground. What next? The pollution keeps on continuing. The PM particulate matter goes on increasing in the atmosphere. Then again, what? You have to bring the cloud seeding again and again. So it is a repetitive in nature, and the impacts are very temporary. Atmospheric constraints, that is, seasonal limitations, mean the technique cannot be deployed year round in moist regions. Okay, it cannot be deployed year round in the moist regions. Next, why use cloud seeding to smog control? So, like that is what we already discussed before. That is, theoretically, rainfall helps wash out the pollutants from the air column, removing pollutants like aerosols, dust, and particulate matter, that is PM 2.5 and PM 10. Artificial rain was proposed as an emergency measure to reduce air quality index levels during severe smog episodes in Delhi. However, scientists caution that cloud seeding cannot replace fundamental solutions. What are the fundamental solutions? Like emission control, industrial regulation, or vehicular curbs. So this has to be major focus rather than temporary solutions like cloud seeding. It remains at best a temporary intervention, not a long-term solutions to air pollution. Okay. Next, critical limitation is cloud seeding addresses symptoms, not causes. Comprehensive pollution controls require systemic policy challenges, systemic policy changes. Okay, so final assessment is at the global level, the success is very mixed. Effective only under ideal cloud and humidity conditions with a significant variability across regions and across seasons. Next, Delhi's case, not very feasible for Delhi because not scientifically viable in dry winter-like conditions that characterize Delhi's worst pollution periods. Even if you bring cloud seeding, it is not going to result in rainfall because of lack of moisture content. Then, future potential. It could be used during the monsoon or pre-monsoon seasons with a better cloud microphysics understanding. Okay, next. So, cloud seeding needs cost benefit clarity, method of meteorological precision, and scientific accountability before policy level adoption. While CAPEX demonstrated measurable benefits under optimal conditions, Delhi's failed trials underscores the importance of matching technology to atmospheric realities. So the technique remains a tool with limited applicability rather than a comprehensive solution to India's air quality crisis. So instead of going for the temporary, we should go for permanent solutions like addressing the root causes for the pollution itself, such as curbing the pollution through vehicular curbs, through industry regulation, through emission reduction. Okay, that should be the way forward instead of going for the temporary solutions. So this is today's topic of the day. If you like the video, then please hit the like button, comment on it, and also share with your friends.